Okay, we're at the top of the hour. We'll go ahead and get started. Good afternoon, and welcome to the third webinar in the National Distracted Driving Coalition's series on technological countermeasures for distracted driving. I'd like to note that this webinar is being recorded and will be made available following the session. So whether you're joining us live today or watching us afterward, we are grateful to have you here with us. My name is Melissa Miles. I'm the Auto Safety Research Program Administrator at State Farm, and I serve on the Coalition's Steering Committee. Today's webinar focuses on advanced driver assistance systems, how the technology supports drivers, and the impact on roadway safety. These tools are becoming increasingly important as we work collectively to better understand driver behavior and leverage innovation to reduce preventable tragedies on our roads. We are fortunate to be joined today by two experts who bring both research and policy perspectives to this important conversation. First, we have Ian Reagan, who is a senior research scientist at the Insurance Institute for Highway Safety. Ian has devoted his career researching traffic safety areas such as crash prevention and driver behavior issues, including driver distraction. We're also joined by Scullion, who serves as the Director of Safety Policy at the Alliance for Automotive Innovation. Paul has worked extensively on a number of safety and advanced technology policy issues, including automated and connected vehicles, advanced driver assistance systems, and cybersecurity. We encourage your engagement throughout the webinar. We will be using the Q&A function in Zoom, so please feel free to drop your questions into the Q&A at any time. If time allows, we'll address questions live at the end of the session. But if we're not able to get to your question today, we'll be sure to follow up afterwards. All webinar registrants will receive an email with the link to the fact sheet and the webinar recording once it's posted to the NDDC website. With that, it is my pleasure to turn things over to our speakers to begin today's discussion.
Okay, thank you, Melissa. I'm going to go ahead and get started. I have some slides to go along with my comments. Happy to be here in this webinar to talk about the relationship between advanced driver assistance and driver distraction. And at the Institute, we believe that the best way to sort of frame this conversation is to think about the design intent of an ADAS system. And so the slides that I have today, I'm going to step through first and talk about ADAS systems that were designed for crash avoidance. And then I'll follow up by talking about ADAS systems that are designed for comfort and convenience. And so this slide just shows some examples of ADAS for crash avoidance that are available to consumers today. Probably the best example would be automatic emergency braking, AEB, or auto brake. So nowadays, most AEB systems also detect pedestrians, but there are also crash avoidance technologies designed to help drivers avoid colliding with in the side of their vehicle. So blind spot warning is probably the crash avoidance technology that drivers are most interested in. It has the highest level of acceptance. Lane departure warning, on the other hand, has some issues with acceptance. So this video shows some of the different systems. So one of the things that this level of technology has in common is that the systems are designed to always be on, but they operate in the background. So they're more or less invisible to the driver until the systems detect that a The intervention could be a brake deployment, a warning, as you see here with the pedestrian, or it may just be a warning that it's alerting collision. And so these systems, they sense input from the driver or the environment and hold off on the intervention until a crash is likely to occur. So we developed a methodology at the Institute a little over 15 years ago that allows us to drill down to the individual vehicle level by working with automakers who have coded the presence or absence of these technologies in the vehicle identification number. We're able to conduct analyses that compare specific make, model, year vehicles with the technology against the same exact make, model, year vehicles without the system installed in the vehicles. And from this series of studies, we're able to show that cars with crash avoidance are reducing the crashes they're designed to address. The biggest benefits that we are seeing has been with auto brake or AEB systems. So if you have a car with auto brake, you have a 50% lower rate of rear end crashes than driving the same make model vehicle that comes unequipped with that technology. And the other percentages that you see on this slide are smaller in magnitude, but they all represent significant reductions in the types of crashes that these systems were designed to avoid. And, at this point, I want to call out a study that was conducted by the AAA Foundation for Traffic Safety. It was published about 7 or 8 years ago. What this study did was to take a large data set that was generated from naturalistic driving research. So this is the Sharp 2 study, if you're familiar with it, where thousands, 2 or 3 thousand drivers were followed for up to a 3-year period. Cameras were in their vehicles. And from that research study, they captured hundreds of crashes that occurred during that time period that they were following the drivers. And they looked to see what type of crashes occurred when drivers were looking away from the road to engage in some distracting task. And rear end crashes are the stereotypical distracted driving crash. And another common crash scenario for associated with distraction were unintentional lane drift crashes. So that study is pointing to the fact that, if you are driving a vehicle with these technologies, you have a level of protection that's available to you that you just don't have if you're driving a car without crash avoidance. So we started rating front crash prevention systems in 2013, soon after we saw some early results that pointed to these large reductions in rear end crashes for having that technology. And this figure shows how quickly automakers responded to that test. The initial test, we only tested to see if the systems could detect uh, a passenger vehicle balloon target. And we tested at relatively low speeds. We didn't go above 25 miles per hour. But you can see as we got to 2023, the test really failed to become a differentiator. And we also saw that there were cars that were receiving the highest scores in our ratings programs, but they were still being involved in rear-end crashes despite the large reductions that we saw with the early versions of the system. So, this led us to revamp the front crash prevention vehicle to test that we conduct now. We did that in 2024. This timeline shows that last year at the timeline at the top right, there's a picture of the targets that we use now in the new test. So in addition to the original passenger vehicle balloon dummy that we still test, that's pictured in the middle, We also are requiring systems to be able to detect and react to the motorcycle dummy that's pictured on the left, as well as tractor trailers. And where we stopped, maxed out at 25 miles per hour with our original test, we now go up to 43 miles per hour. And so, where we are today with testing at 2026 model year vehicles is, about half of the cars that we've tested are getting good scores on this much more difficult test. And, some consumers are, sort of scratch their heads when they see that over 90% of the 2023 vehicles received the top score, but only 46% received the good score with the under 2026 model year. But when they understand that the requirements are more difficult, it makes sense. So just kind of rounding up my comments about uh, driver assistance that's designed for crash avoidance, I wanted to highlight this slide because it's a really positive data point, given that AAA Foundation study that points to the very strong correlation between looking away from the road and getting into a rear end crash, combined with our work that shows if you have a car with front auto brake, you have a 50% lower rate of rear end crashes. And that reduction is for the older generations of auto brake systems that are not as capable as the ones that are getting our good ratings now. So, while that is a positive finding, I like to show this figure here because the previous slide showed the availability of new vehicles, 2025 model year vehicles. But this slide shows the percentage of vehicles that are on the road in 2025 that had AEB with pedestrian detection. And, this just captures the fact that most vehicles on the road are much older than 2025 model years, and they don't have the technology. And so we can't just assume that driver assistance designed for crash avoidance is a panacea for distracted driving. And, it's, the fact that it's going to take until about 2050 till we get to 95% of the vehicles on the road with this technology is just a reminder that we really need to double down on all of the other distracted driving countermeasures that are available to us. Um, so I want to shift gears a little bit and spend the rest of the time that I have talking about advanced driver assistance that's designed for comfort and convenience. And so this is a different picture when it comes to driver distraction, and the technology is different. So at the Institute, when we are referring to ADAS for comfort and convenience, we're basically talking about adaptive cruise control, which maintains a set speed of the vehicle and adjusts the set speed for based on the speed of the traffic ahead. The ACC systems now will take you all the way down to a stop and will get you started again. And so we also have lane centering technology. And this is a little bit different than the crash avoidance lane departure prevention systems that provide a little bit of steering input if you're about to drift out of your lane. Lane centering is continuous steering support. So, if you have a lane centering system, the driver essentially should not have to steer much at all. And when you combine ACC with lane centering, you have a partial driving automation system. And one of the big differences between partial driving automation, ACC, and lane centering and crash avoidance is that the driver has to choose to activate these comfort and convenience features, whereas the crash avoidance systems are designed to always be on. And these systems also provide continuous input. So this video that we have doing our research.
And we're not able to hear you over the audio of the recording. I don't know if you can mute those.
Oh, no, okay. So I'll just pause and say that these systems are different depending on the automaker. Some are designed to let you take your hands off the wheel, and some are not. This system is uh, that's being tested right now is designed for drivers to keep their hands off the wheel. So the driver is testing to see what happens when you take your hands off the wheel for a long time. And and so there he was testing to make sure that there was a hands-off wheel warning. In this next video, we see a system that allows for drivers to take their hands off the wheel, and the engineers are testing to see what happens if the system will detect this long period of inattention when the driver has their head buried in their cell phone.
Please take control of the vehicle now.
And so in that last video, we were interested in seeing if the system would initiate a safe stop procedure if the driver just failed to pay attention to the reminders telling the driver to take the wheel and to pay attention. Our concerns with this partial driving automation is that when we conducted our research to see whether or not this technology offers any crash reduction, um, where we saw these massive reductions, statistically significant reductions in crashes associated with ADAS for crash avoidance, we aren't seeing any difference in crash rates for vehicles with partial driving automation compared to the same make and model vehicles that come unequipped with partial automation that only have crash avoidance. And what we have seen with these studies, when we look at what happens to driver behavior when they use these systems, is that they are just much, much more likely to be disengaged and from the driving task and multitasking with their cell phones, eating, drinking, grooming, and the like. And we've even seen that drivers will begin to learn um, when the system is going to alert them. So they will be as distracted as they can be during the window when they know they won't get an alert, and then pay attention just long enough to satisfy the system and then go back to being distracted. But our big concern with partial driving automation is sort of summed up here in this slide. The limitations to partial driving automation is embedded in its name. The systems are not full self-driving technologies. Drivers cannot buy a partial driving automation and assume that it's going to drive for them. And the even bigger sort of challenging problem to address is that as these partial driving automation systems become more and more capable, the people who drive the more capable systems are even more willing to say that their system is full self-driving, despite limitations that are plastered all over the owner's manuals, telling the driver that they are ultimately responsible because the systems cannot detect everything out in the road. We see that about half of the owners of Cadillac and Teslas with partial driving automation are willing to treat their vehicles as full self-driving. And because of the studies we've done that show this big behavior change, this increase in distraction when they're using partial automation, we've seen that in-house. And we've seen that that type of inattention and driver disengagement has been implicated in several fatal crashes that have been investigated by the NTSB, where drivers were using partial automation, and the NTSB concluded that they were inattentive in the moments that led up to the crash. Because of these findings, we introduced our partial automation safeguard ratings in 2024. And these ratings are very different from all of the other ratings that we do, where we're trying to encourage automakers to deploy a technology. Our safeguard ratings, we are not trying to encourage automakers to deploy partial automation. We don't see a safety benefit, a big safety case for the technology. What we're saying with the safeguard ratings is that if automakers do implement partial driving automation, that they need to make sure there are safeguards in place that do their best to bring the driver back into the loop. So when the system does fail, because they all do, that the driver, has a chance of recovering and avoiding a crash. That brings me to the end of my comments. I hope that this was helpful to you to see why, it's really important to consider the design intent of an ADAS system when thinking about how it might influence driver distraction. So I want to thank you for the opportunity to be here today, and I will go ahead and pass things over to Paul now.
Awesome. Thanks, Ian. And thanks to the NDDC for the opportunity to participate on today's webinar. As Ian mentioned, we're at an exciting time in the evolution of automotive safety. This is being driven by the significant investments that industry, both OEMs and suppliers, are making in some innovative safety technologies. This includes the advancements in crash avoidance technology that Ian just described. It's really sort of allowed us to shift the conversation beyond crash protection, which continues to improve, but looking more towards how crash avoidance technology can really help us reduce the likelihood of serious injuries and fatalities on our roads. So some of the data showed earlier, manufacturers are increasingly offering ADAS features as standard equipment in their light-duty vehicles, and the voluntary commitment by industry a number of years ago to install AEB as standard equipment has really sort of paved the way for crash avoidance systems that can leverage the same sensors to provide sort of more functionality. For example, the cameras that monitor the forward roadway to support automatic emergency braking, these can also be used to provide sort of lane departure warning and lane keep assist. And this helps improve safety for consumers and helps support increased affordability by leveraging the same sensors to do more. But as Ian mentioned, however, with any new technology, it's really important that drivers both understand the capabilities and limitations. And this is particularly important for ADAS features, especially those crash avoidance technologies that are only designed to intervene when there's a sudden change or unexpected change in the traffic conditions, such as a vehicle suddenly applying the brakes in front of you. The driver is still required to maintain focus and attention on the forward roadway, which I think is a core tenet of the NDDC. And this really means eyes on the road, keeping your hands on the wheel, and really trying to avoid any of those secondary tasks, such as using portable devices, for example. The same is true for those ADAS driver convenience features that you mentioned that provide sort of higher levels of automated driving functionality, really intended to help reduce the burden of driving, such as combined lane centering and adaptive cruise control. And vehicles equipped with these convenient features increasingly include driver attention management systems and the industry is taking proactive efforts to try to establish some general principles around how these systems are designed, and that includes driver warnings, driver re-engagement, and detection and potential misuse or abuse of the system when it's active. And Ian showed a few moments ago the IIHS rating criteria. But the industry principles, they really provide a baseline that OEMs and suppliers can follow and build upon. And companies are continuing to invest in improved system designs for really ensuring that the driver remains engaged in the task, which I think is expected when those systems are active in vehicles. A really big piece that industry continues to look at, and as the safety conversation really evolves from crash protection to crash avoidance, and really looking now to driver support features that can encourage safe driving behavior. Consumer acceptance is a really critical piece of that equation, and really research is looking at ways that how these systems can really promote attentive driving, perhaps in conventional vehicles, while avoiding situations where the driver may seek to turn the system off. So, for example, one of the use case scenarios that could be looked at is leveraging how in-cabin sensor data could potentially be combined with information from outside of the vehicle using those ADAS sensors to provide more contextual driver alerts, whereby the timing and intensity of warnings are adjusted based on maybe the driver's level of inattention and the surrounding roadway conditions. So, for example, if the driver warnings could be tailored differently in sort of high density traffic situations versus open highways where there's not much traffic, and that would again provide sort of more context and perhaps understanding to the driver about why alerts are being provided in different situations. So I think the bottom line is that, for the vast majority of new vehicles on the road, the driver still has an active role and must be available to perform the driving task. And this really applies to both vehicles equipped with ADAS, crash avoidance technologies that provide that sort of last minute intervention, as well as convenience features or vehicles equipped with driver attention support. And until we sort of see more fully self-driving vehicles on the road, building that understanding about the capabilities and limitations is going to be really important. And we support efforts to educate both new and experienced drivers on appropriate use. And that could include, through programs such as the New Car Assessment Program, as well as looking at ways that current driver ed programs could be structured to ensure that there's an increased emphasis on kind of what the modern fleet looks like, particularly as some of these ADAS features become more commonplace. So I'll pause there just for a moment and maybe pass it over to Melissa. And I know you have a few questions lined up for us before we jump into the Q&A from the broader the audience.
Yeah, great. Thanks, Paul. And thank you both for the information shared today on advanced driver assistance systems and crash avoidance technologies. As I mentioned to the attendees earlier in the webinar, we welcome your questions. Please drop them in the Q&A if you do have any questions for Ian and Paul. I'll go ahead and kick off our Q&A with a question for either of you. What are some of the common questions and misconceptions about ADAS?
Yeah, I think I'll maybe jump in on that one. I think it's sort of maybe an extension of some of the comments I made previously. I think the real thing that we want to make sure that consumers understand is that there continues to be an active role for the driver in monitoring the roadway task and being available to respond to when there's changes in traffic conditions. So the driver shouldn't be relying on the system to sort of a crutch, if you will, to engage in sort of unsafe secondary activities while behind the wheel. So I think that's a really important point to emphasize, in addition to, other positive driving behaviors, making sure the driver remains sober and avoid sort of speeding, etc.
Yeah, I would add, one of the common misconceptions I think is that the sort of wrapped up in that willingness to treat partial driving automation as more than it is. And I think to the extent that drivers really understand the capabilities and limitations of the system, they could be more likely to use it appropriately. And I think one of the concerns with crash avoidance, we haven't seen strong evidence for it, but we would not want drivers to go away thinking that because you have crash avoidance technology that reduces crashes, that you have carte blanche to drive distracted. These systems are reducing crashes that are associated with distracted driving, but that doesn't mean that they're capable of avoiding all crashes or, that it just makes it okay to pick up your cell phone.
Yeah, great points, both of you. We do have a question in the Q&A. Is there evidence that drivers are becoming dependent on features like blind spot monitoring?
Well, there is some evidence that some researchers have shown that drivers do shoulder checks less when they have blind spot monitoring than when they don't. But we have research that shows that blind spot monitoring cuts down on the types of crashes that blind spot monitoring would address, that they're supposed to address. So those lane changes where you're intending to change lanes, but somebody's in your blind spot. So those crashes are occurring less often if you have a car with blind spot monitoring, but you are changing your behavior. You're not checking your shoulder as much as you used to because the system is providing you that warning. So there's some of the nuances with some of these results that you really have to think about when you're trying to understand the findings.
We have another comment question in the Q&A. Thank you for the presentations. Do you believe that the use of terms such as full self-driving system by manufacturers could lead to confusion among drivers?
I think this is a topic that's obviously gaining a lot of attention. I think it's something that the manufacturers continue to look at in terms of how can you best communicate the features and functionality that a system may provide. I think at the top level there are certain naming conventions, but I think fundamentally it comes down to sort of how you can educate the consumer about the capabilities and limitations of that system. So it's not just in the name per se, but sort of how you can educate the driver about what the system capabilities are, what conditions that it operates under, what the driver's role is, which I think, for most of the lower level automation systems that are available in the market, the driver continues to sort of maintain a role there, as well as sort of understanding, to the extent that there are driver attention support systems included in that vehicle, the conditions that they might expect to get an alert or a warning, so that that they understand that's the system, how the system's intended to perform. It's intended to help support safe driving behavior, but at the same time, it shouldn't be used necessarily as a crutch to engage in some of those perhaps more unsafe or distracting behaviors.
Great. We've got time for two more quick questions. I've got one in the Q&A. Is there a risk that drivers may not be capable of taking over when prompted in an emergency situation? So, for example, they have become so reliant on the system that they de-skill themselves.
I think that is a concern, particularly for the higher levels of automation, compared to the systems the crash avoidance systems that just sort of operate in the background. And I've probably seen this come up more with parents looking to teach their teens to drive, and there's in that space, that's a big question. Do I teach my teen to drive with a car that's equipped with ADAS technology, or do I teach them how to drive without it? And I think there are people on both sides of the fence there.
Yeah, I think in general, at least for the time being, there should continue to be an emphasis on driver training to make sure that they're capable of operating the vehicle under sort of the license requirements. But I think over time, there may be situations where the automated technology becomes more advanced. I think the ideal scenario is to try to sort of avoid situations where there is a need to quickly resume control, and the more of a handoff that you can provide to the driver, I think that sort of creates more of a cushion for that transition, so that they're not suddenly sprung into a situation which they may be unfamiliar or uncomfortable with. And it may be sort of as automated technologies evolve, that sort of the challenges associated with that may go down also. Additionally, there are systems being developed around emergency situations where the driver may become incapacitated during the journey, where the vehicle is capable of bringing itself to sort of more controlled stop in those types of situations. And to the extent that those types of use cases continue to expand, maybe relying on sensors to sort of perhaps pull to a safe space, those are again those safety situations that could potentially be addressed.
Yeah, great point. So our last question of today, before we wrap up our discussion, what are some actions that drivers can take to help prevent distraction and related crashes?
Well, I would start by um, making a plug for using do not disturb while driving features on your cell phones. That's one simple way to try to prevent distractions from coming into your vehicle. Um, and you know, people's intentions do matter as well. So, if you can set the intention to not use your phone, um, if you really believe that, you know, you should stay off your phone and you can really stop and take a moment to set that intention before you start out. Um, those types of individual drivers are less likely to drive distracted than people who don't really think about that sort of thing. Um, that's all separate from ADAS, but I think those are things that people can do to help them avoid distractions.
Yeah, I think just perhaps as a core takeaway and sort of the risk of sounding sort of repetitive, I think it's it's obviously important that drivers, and it's along the lines of what Ian was saying, continue to keep their eyes on the road, hands on the wheel, and sort of minimize potential device use when systems are engaged. To the extent that there are um, evolution in the systems that we find in vehicles where they're able to contextualize the environment to provide alerts to the driver when sort of high degree of inattention is detected, and that can provide sort of warnings. Those are some of the technologies that perhaps that folks could look at towards in the future. And also just as a baseline, I think looking at crash avoidance technologies in general as kind of an investment in safety.
Yes.
I think it's really important to understand the capabilities and limitations. I think the more that people sort of recognize the benefits that those technologies have in terms of safety, um, both in terms of reducing the risk of serious injury to both themselves or others. I think that's really where the true value can come. But otherwise, as we continue on our path to more automated vehicles, recognizing that the role of the driver hasn't fundamentally changed, but it's important that we bring the consumer along and drivers along so that they are aware of kind of the journey, and it's not sort of being passed on them without their awareness. So education is going to be a big piece, and definitely welcome the work that the NDDC and the other participants in the other sessions have and the perspectives that they bring to the table as well.
Yeah, that's great. Ian and Paul, thank you both for the insights that you've shared today. That wraps up our webinar on behalf of the National Distracted Driving Coalition. Thank you all for joining us and have a great day.
Thank you very much.